Hi, let's see how to do BFS search in a graph. To do that, we would need three things: a queue that implements first and first sub principle, a visited array that takes account all the nodes which have been visited or not, and an answer array. We have named it BFS answer. First, we'll push the first node of our graph, that is 0, into our queue. As we are pushing it, we'll also tell that we have visited that by turning false to 0 in that visited array. As it is our first node, we'll add it in the answer. Next, we will see all the neighbors of the first node, that is 0, that are 3 and 4. 0 connects to 3, 0 connects to 4, and write it down in our queue. We'll also change its visited type from false to 0. We'll cut it here as we have visited all the neighbors of 0. Then we'll take 3, we'll write it here and see what all neighbors are of 3, that are 1, 0 and 4. 1 is not visited yet, so we'll write it here, and 0 and 4 will check. 0 has been visited, 4 has been visited, so no need of writing them. Now we'll cut 3. Now next comes 4. We'll write 4 here and see all the neighbors of 4, that are 2, 0 and 3. We'll check 2. 2 has not been visited yet, it is false, so we'll write 2 here and change it. We'll check 0 then. 0 has been visited as well as 4 has been visited. Now we'll cut it here. Now we'll come for 2 first. 1, we'll check the neighbors of 1, also write it down here. We'll check the neighbors of 1, that are 3. 3 has been visited, so this part is done. We'll cancel here. Then we'll come to 2. 2's neighbor, before checking its neighbor, we'll write it down here. 2's neighbor is 4 and 4 has been visited. So this graph has been completed. This is the BFS answer. Now we'll see the coding implementation of it. In the last video, I taught you how to write an adjacency list for a graph. We'll continue from here. We'll remove this as we don't need to print the adjacency list. Let's start with the coding part. First, we will need a visited array, not visited, vector array, named visited. I'll use the value 0 if it has not been visited and 1 if it has been visited. The total number is n because n is a number of nodes, and an array called BFS ans that contains an answer. Now we'll traverse through all of our nodes. For int I, there are a total of n number of nodes, so n. Now if the node has not been visited, we'll do BFS search on it. I'll enter the arguments later. Now let's write the function for BFS search. Void BFS. First we would need is a queue. We'll push the first value of our graph, that is 0, into the queue. Queue.push. Let's name it node. We'll change that the node has now been visited, so change that 0 to 1. Now we'll iterate through the queue till it's empty. We'll store the first value in front node. And pop the first value of our queue. While popping, we'll also add that value, that node, to our BFS ans. Push back. Front node. So for example, when we are pushing 0 into the queue, we'll change its value from false to true, that it has been visited, and also add it to our BFS answer vector. Next, we'll check who are neighbors to 0 and add them to the queue as well. We'll use our adjacency list for this. Check for a front node, and if the node has not been visited, the neighbor has not been visited, then push it into a queue. And while pushing, also change that it has now been pushed, so change its visited value from 0 to 1. Now when our BFS answer is ready, we'll see out, print it out. So for print I in BFS hands, we'll see out I. The last thing left is to enter arguments of BFS. So let's check what all we needed. We needed the visited array, so vector int visited. We needed the adjacency list, so this thing, I'll just copy it. We needed our vector answer array, BFS ans, and the value of the node we are iterating here, I, that is. So what all we needed, visited, our adjacency matrix list, sorry. So the ADJ is in the graph class, so we'll have to use g.adj here. Next is BFS ans and the node, that is I, and this should work. Let's run it out. Number of nodes are 0, 1, 2, 3, 4, so total number is 5. Edges is also 5. Let's quickly write down u and v. So 0 is connected to 3, 0 is connected to 4, 1 is connected to 3, 2 is connected to 4, and 4 is also connected to 3. So 0, 3, 4, 1, 2, and that was our answer to BFS ans. Let's go back and check our code again. So what we updated from our previous video, from our adjacency list video, was implementing BFS. We needed visited array, BFS answer array to store our answer. We one by one check all the nodes, and if they are not visited, we implement BFS to it. And in BFS, we have a queue, that is this part, and we add value 0. We change that 0 is now visited, so change it from false to true. Then we go on and add that front node, that is 0, to our answer array, and after adding, we check all the neighbors of 0 here, and while checking its neighbors, we push it here into the BFS answer, and also change the visited value from false to true. This stores all of the BFS answer into our vector array called BFS ans, which we see out in the end. 0, 3, 4, 1, 2.